it turns out that chemistry and electricity actually form a pretty natural partnership. So we tend to see chemistry and electricity overlap, especially in redox reactions. Okay, because we got to transfer electrons from one species to another. We also see electricity and chemistry coming together, especially when we form a battery. And then finally, another example of chemistry and electricity coming together is electroplating, where we can use electricity to deposit metals onto the surface of another metal. Okay, so we can summarize these examples as this: that electrons are going to move between chemical species. Now, there's two possibilities of how the electrons move between species. One possibility is that the reactants can form products and then release electrons. Okay. And this is a chemical reaction that provides electrons with energy for other uses. So the reactants give up these electrons, we form products, and then these electrons are used to drive other processes. So the text refers to this reaction as a spontaneous chemical reaction that generates an electric current. Now, the type of cell that we can form is called the galvanic or the voltaic cell. So it's going to have two different names. And the form of this kind of a situation is a battery. Okay. Now, it's also possible that you could have reactants and you take those electrons and it forms products. Okay. And so what the text calls this is that an electric current that drives a non-spontaneous process. And a type of cell for this type of reaction is called an electrolytic cell. Okay. And an example of this is, let's say you're taking water. Okay. So let's say you got 2 moles of water and you're trying to split the water to form hydrogen gas and oxygen gas. Okay. So this is the electrolysis of water. If you run an electric current through water, you can actually split water molecules into hydrogen and oxygen gas. All right, now near the end of chapter 18, I showed you this kind of a graph. Okay, so if we take a look at the free energy, considerations from this, okay, the non-spontaneous reaction, this is the electrolytic example. The spontaneous process is the voltaic cell. Okay, so the spontaneous process is the voltaic cell. The non-spontaneous process is the electrolytic cell. And again, right here at the minimum point, that's the equilibrium. Okay, and so the voltaic cell is going to be going towards equilibrium. The electrolytic cell is going to be going away from equilibrium. So we need to provide a lot of energy to make the electrolytic reaction occur. Now, since electrons are gained and lost, okay, we know that the central chemistry of everything that's involved is oxidation-reduction reactions. And so that's where we're actually going to start in this chapter. Let's review, how do we balance oxidation-reduction reactions?